Today's lesson will be on absolute value. I figured we'd need a little review on solving absolute value equations. Steps for solving. First, isolate the absolute value bars. Second, remove the bars and make the other side plus or minus. Solve both equations, then check for extraneous solutions. Extraneous, that means that they're extra and they're wrong. So they solve the original, they don't work if you plug them back into the original equation. So absolute value equations, you have to check. Example 1, let's solve. So the first step says isolate the absolute value bars. So I want to get rid of the 3 on this side, and I get the absolute value of x equals 3. The next step says remove the bars and make the other side plus or minus. There's nothing left to solve. Then the last step, and it's mandatory, is to double check for extraneous solutions. So if I take my original equation and plug in the answers, I have to check and see if I get a true statement. The absolute value means the distance from 0. So all you really have to do is make the number positive. So that's 6, and that does equal 6. So positive 3 works. Now I'm going to double check to see if negative 3 works. Does negative 3 plus 3 equal 6? Well, you just make it positive when you remove the bars, and 6 equals 6. So both of these work, and I did double check. Alrighty, let's move on to example 2, and let's go through the steps. First, we want to isolate the bars, so I'm going to add 1 to both sides. Now I'm going to divide both sides by 2. Now I've isolated the bars. So now I remove the bars and make the other side plus or minus. And now I solve both equations. So at this point, I could split and make 2 equations, but I think I'm going to go ahead and add 2 to both sides. Now, I want you to watch this step. I'm going to put the plus or minus between the values. And the reason I'm doing that is because later when we get to the quadratic formula, I want you to get used to plus or minus being in the middle. So now I have 2 equations to solve. One where I use the plus sign. And there's really nothing to solve. I'm really just combining like terms. And now I'm going to do the one with the minus sign. So here I get x equals 6. You always have to simplify. Ooh, and I should not put a box around that because I have not checked it. And x equals negative 2. So now you always have to double check into the original equation. So I'm going to check x equals 6 into the original. So I'm going to plug 6 in where the x was. And it's important to never cross the equal sign. So now I got the absolute value of 4 there, minus 1. And now I take the absolute value, which is positive 4. 8 minus 1 is indeed 7. So this one checks. So this is a good answer. I checked it. Now I'm going to check the negative 2. So if I plug negative 2 in place of x, in place of all the x's, let's see if it's going to work. I get the absolute value of negative 4, which is just positive 4. Remember, the bars will always make it positive. So I get 8 minus 1 is 7. Now soon, we're going to see weird stuff happens when we have variables in the bars. We're going to see that. So both of those solutions checked out and worked just fine. Let's move on. We want to isolate the bars. They're already isolated. So now I'm going to remove the bars, make the other side plus or minus. Be very careful to put parentheses. I'm going to go ahead and add the 3 to both sides. I could split off into 2 equations first, but I just kind of like to have the x by itself. But you totally don't have to. These parentheses are mandatory though. So now I'm going to do an equation with the plus sign. And I'm going to do another equation with the minus sign. So now I got to go with the minus. On the first equation, I really don't need the parentheses. I'm going to subtract 3x from both sides. I get a negative 2x equals 8. Our x equals negative 4. And when I solve this equation, I have to distribute this negative sign. So I'm looking at a negative 3x minus 5. I'm going to add 3x to both sides. So I get 4x equals negative 2, or x equals negative 1/2. Imperative that you check both solutions into the original equation. So I'm double checking and I'm plugging in negative 4 for all the x's. And I'm going to double check the negative 1/2 also. So I got negative, nope, that's not a negative 4. I forgot over here. I'm checking negative 1/2 into the original equation. And I'm going to see if it's equivalent. So I need to double check both of the solutions. So here I get the absolute value of negative 7 is just a positive 7. And now I'm going to simplify this side. I get a negative 12 plus 5 is negative 7. So these are not equivalent. That means this is extraneous. It is not one of the solutions. So now I'm going to check this one. Now, if neither work, I would say no solution. But let's see what happens here. Let me get a common denominator. So I get a negative 7 over 2. The absolute value gives me a positive. And now I'm going to simplify this side. I get a negative 3 over 2 plus 5. I'm going to make that 10 over 2 to get my common denominator, which is 7 over 2. So this side works. So my only solution is x equals negative 1/2. Okay. Now, before I move on, let's review that process. We had to go plus or minus. Okay, when you remove the bars, plus or minus on the other side. And that gave me 2 equations. You could also split the equations from here and go with x minus 3 equals a positive 3x plus 5. And I could have said x minus 3 equals a negative 3x plus 5. And I could have solved both equations from there before I moved the 3 to the other side. Doesn't matter. It would come out the same as long as you remember to distribute. Okay, I just wanted to make sure you understand when I solved those 2 equations, I got x equals negative 4 and negative 1/2. And when I double checked, negative 4 did not work when I plugged it back in to the original equation. Alrighty, let's move on to our final example. We're going to graph. And we're going to see that it works like every other function works. So absolute value gives you a V shape most of the time. So here, my vertex is -3, -4. Remember, we go opposite, same. So I go to -3, -4. And now, this number out front kind of acts as a slope for my V shape. Rise 2, run 1. Rise 2, run 1. So forth and so on. And we do the same thing. Mirror image. And there's my V shape. Also, if A is negative, it flips down. Okay? I like to graph it first and then flip it down. So always remember that. This one, though, the leading coefficient is positive. But if it had been negative, it would flip down.